Hi guys, I'm Fera from Guitars AI, and I welcome you to this first notebook in this series of Jupyter notebooks where I'll be discussing some standard, classic, important algorithms and implementing in 4 different programming languages. JavaScript, Python, Java, and C++. In this first notebook, I'm going to talk about the MergeSort algorithm, which is a very efficient sorting algorithm. It's a divide and conquer algorithm from the mid-40s. So we use it to sort a list or an array of elements. For this first notebook, I'm also including a way to transform a Jupyter notebook into microservice server, so we can use the MergeSort algorithm that we're going to create, transform a notebook to receive requests, and we can test over the internet, and kind of a REST API microservice just for this first tutorial. So let's get started. As usual, we can go to Guitars AI GitHub. Guitars AI GitHub. We can Google it. Click on the Guitars AI GitHub link. We reach the Guitars AI GitHub. Feel free to explore other repositories. Some are just for tests, are very not well organized, but some are the other series of tutorials and Python notebooks that I prepared, like computer-aided musicology, basics of musical instruments classification using machine learning, basic Python tutorial, some other applications. But for this one, we go to repositories and the algorithms repository. So discussion and implementation of standard and classic important algorithms in Python, JavaScript, Java, and C++. So I pre-configured an environment, an interactive environment that you can test using Binder. So you can click on the launch Binder, and there will be this page displaying. You load the repository and build an image. So because I was testing many times, the image was already built, but it can take a long time. It's a very powerful environment, so it's installing a lot of packages and a lot of different things, configuring, so it can take a long time. So if it happens, just be patient, and if it fails at some point, it can be a timeout, and you just can try to launch it again. So here we are. This is our Jupyter, and it's going to be the MergeSort. It's the first notebook in the series, and once it's open, we can start. So it's loaded. We can close the console, which is this part here. We're not going to use it. And now we have our Jupyter notebook, and it's thanks to the script of script extension for Jupyter, we can run many different languages in the same Jupyter notebook. So we can have JavaScript, Python, Java, C++, Octave, R, Bash, many others, but I didn't install. And let's get our hands dirty. So first, I'll do some imports and configuration for Python. And just for the Python implementation, I'm putting a lot of log messages so we can see almost step by step what the algorithm is doing, because sometimes it can be very tricky to understand what's going on, especially when recursion is involved, and it's very easy to get lost and With this logging messages, we can see almost step by step in which function we are and what are the arguments, what are the output. And so just for the Python algorithm, I prepared this. For the other languages, it's just the implementation without any debugging or any logging information. So I'm using the Python display HTML just for showing web pages inside the Jupyter Notebook. This part here, I'm just configuring the logging so we can have this log messages. And this is just an auxiliary function to display a website inside the notebook. So we can run the cells. So Shift Enter, and we will load and start running the cells. At this point, I'm show web that I'm going to show the Wikipedia page of MergeSort, and I'm just using this because later on I will export this notebook as a Python module, and I will use this Python module to create the microservice, and this is the reason I'm using this in many points. So what's the MergeSort algorithm? So the MergeSort algorithm is sorting. It produces a stable sort. It has a complexity of n log n, and yeah, it was created in the mid-40s and is a very efficient way to sort arrays or lists of elements. So here we can understand how it works. So let me start again from the beginning. So we have a list. We will split this list until we reach a list of one element. And by principle, a list of one element is already sorted. Then we will merge these lists of one element, making sure that the elements are sorted. So this merge algorithm will compare the elements of two arrays, and it will place the sorted element in the correct position. And we will do this for every group of lists. So we started with single elements, we merged two elements, and then we merge again the lists into from 2 to 4, and then these two will be merged again, and we will have a complete array, sorted version of the unsorted array that we passed. So how did I attack this problem? I will create a splitting function. I will create a merge function. I will create a MergeSort function using the split and the merge. And this MergeSort will use some recursion, and we will end up with the full sorting algorithm. So you can read on Wikipedia more about the this algorithm. And let's start with Python, defining a function to split a list. So we will pass an array or a list. In this case, I'm passing a list. And it will take a list as an argument, and it will return a list with 2/2 of the list we passed. So how it is doing this? We will find the middle point of the list. So that's what we're doing here. We'll find the index of the middle point of the list. So in case the list is with an odd number of elements, it will split. For example, if it's 5 elements, it will have 2 and 3, or if it's 8, it will be 4 and 4. So we were using this list indexation of Python. So we're splitting our input lists, finding the middle point, and dividing in 2 lists, and returning a list with 2/2 of list. So we can run the cell to define the function. And here is a test of the function. So we are passing a list with a 1, 2, 3, and we want to return 2 lists. So this is the login mesh as I mentioned. We're inside the function split, so we're inside here. The input arguments are 1, 2, 3. We're calculating the index of the middle point, which is this part, and we're returning a list with one list of 1 element and a list of 2 elements. So we're not doing any sorting, we're just splitting one list in 2 lists. So have in mind that a list with 1 element is already sorted, and our merge function will assume that the input list we're passing to is already sorted. So we start with a list of single elements and we're going to merge them in a sorted order. So in Java, I am doing the same thing, just defining the middle point. And so Python has this very convenient way of splitting lists. In Java, I'm using the slice, and I'm returning the left and the right. So we can also define the function, and there is the test of the function. So we have the result, a list with 1 and then 2, 3, which is what we passed. We reached the implementation in C++, and in any programming language we have a choice of different data structures to use depending on our problem. We can also create our own data structures, but in this example I'm using the vector, and for the C++ use the list in Python. We could have used a NumPy array, so we have an extensive choice in data structures. Be aware that in this Jupyter Notebook, if you run the same cell of the C++ kernel twice, there will be an error. So you're giving multiple definitions of the same function or the same variable, and this will cause an error. So if it happens, just try to restart fresh. And so I'm including a vector library. Here I'm just for demonstration purposes, I'm defining a type. It's a vector of vectors. It is a vector of integer vectors. And here we can run the cell. Here is defining the split function in C++. It will return a vector of vectors, and it will have as an input argument a reference to a vector of integers. So we are splitting this vector of integers into 2, finding the midpoint, and then returning the first half and the second half. So we can also run the cell, and here we are using the same test vector as before, and we have now a vector with 2 vectors inside, split in the middle. In Java, let's import, I'm using array list, or maybe I will not, I am. And this is the function. So this is returning a jagged array, and it takes as an input an array of integers. We find the length of the input list, then we use the length to calculate the midpoint, and we are copying the list until the midpoint to the left side, copying from the midpoint to the end to the right side, and as a result we are returning a jagged array with the left and the right part. Here is the test vector, and here's just a function to print the elements on the screen. So we have the first half and the second half. So this was the split function. We are going to use this split function as a building block of our final merge sort function.